Now, next type of projectile motion, that one is angular projection. Students, in previous case, I thrown your object from the top of the tower or somewhat height of the tower. Now, in this case, I am going to throw an object from the surface of earth or somewhat ground. But I am throwing somewhat angle. In previous case, there is no angle present. Here, I am going to throw an angle somewhat, I don't know, somewhat angle. So, this type of motion is called angular projection. The same manner, horizontal projection and angular projection are going to discuss. First, I am going to prove this type of motion is a parabolic motion. And before that I told you projectile motion is a parabolic motion. So now I am going to prove this as a parabolic motion. And before that we will discuss some of the factors present here. So I am going to throw an object in somewhat initial velocity u. This velocity will be resolved into two components. One is horizontal velocity and then one more is vertical velocity. I am going to take it as horizontal velocity ux is equal to u cos theta. And then vertical velocity can be taken as uy is equal to u sin theta. The two vectors are resembling in somewhat direction, so I am going to draw the resultant vector u. Sir, you just listen here. Students, listen here. Here, the two types of velocities are acting at the same point. So, you throw the object in initial velocity, it will be travel in the direction of against of gravitation. Am I right? It will be traveling in the upward direction. So, the upward direction is only acting when the initial velocity is lost. Then only the object will gain the maximum height. Am I right? So, initial velocity is acting on the throughout the motion, and the vertical velocity of the gravitation should be attracting in every point. So, here the gravitation is attracting, but the gravitation was too small here. When the point initial velocity and then vertical velocity becomes equal, that point is the maximum height of the point here. So here the vertical velocity becomes 0, only the horizontal velocity is presenting for the constant value. Am I right? So, okay students, listen, here the vertical and then horizontal velocities are coming to same. Afterwards, it will be move on the fully influence of gravitation force. Okay, now let me discuss. To prove the parabolic motion, I am going to take the motion of x-axis, that is horizontal direction. So, motion in horizontal direction. Am I right? Horizontal direction. Here, the velocities are split into two vectors, two components. One is horizontal and then vertical. Okay. Let me take the second equation of kinematic equation. S is equal to ut plus of at square. Am I right, students? So now I am going to find out the motion in horizontal direction. So I am going to fix as a Sx is equal to ux of t plus of 1 by 2 ax of t the whole square. Am I right? So once the horizontal direction, the horizontal velocity remains constant and the acceleration becomes 0. So this term will be vanish out. Am I right? So Sx can be replaced by x and ux can be replaced by u cos theta. So ux is equal to u cos theta. So into t. For my future purpose, I am going to take it as and modify t is equal to x divided by u cos theta. And then, so we find out the motion in horizontal direction. Now let me move on to motion in vertical direction. Motion in vertical direction. What is the formula for kinematic equation? Sy is equal to uy of t plus of 1 by 2 ay t square. Here Sy is representing the y component, that is the height of the object. So y is equal to, what is the initial velocity of uy? Uy can be taken as u sin theta into t plus of 1 by 2. What is the value of ay? Ay is the acceleration due to gravity in vertical component. But the object is traveling upward direction, that is against of gravitation. So you should put the negative sign. So ay is equal to minus of g. Am I right, student? Yeah. And then minus of g into t square. You know very well about the value of t. For the future purpose, I already measured here. So I am going to substitute these values. So y is equal to u sin theta. The value of t is x divided by u cos theta minus into plus minus 1 by 2 g of, what is the value of t here? X square divided by u square cos square theta. Am I right? By simplifying this equation, y is equal to, here u will be cancelled, so x sin divided by cos can be written as tan theta, and then minus of 1 by 2 x square divided by u square cos square theta. This equation represents the inverse parabolic equation. So in previous case, horizontal projectile motion proves parabolic motion. Here the angular projection proves the inverse parabolic equation. Am I right, student? So next, maximum height. What is the maximum height reached of the projectile in an angular projectile motion? So the height is relevant to the y component, that is vertical direction. So there is no horizontal direction present. By using the third equation of kinematics, because the velocity and then acceleration is comparing that equation. So velocity, vertical velocity is mainly dominating to reach the height. So I am going to take that equation. What is the third equation? V square equal to u square plus 2as. Am I right, students? Yeah. We are discussing only about the vertical velocity. So I am going to fix the suffix value of y. That is a y component of velocity and then acceleration. What is the vertical velocity of final velocity Vy? Sir, we can't able to find, sir. So final velocity of y component becomes 0. Am I right? And then we know very well about the initial velocity of vertical. So uy can be written as u sin theta. Am I right, students? Yeah. And then what is the value of ay? Ay is the acceleration due to gravity acting on the vertical direction. The particles traveling in upward direction, so against of gravitation, so you should put the negative sign of acceleration minus g. And then what is the displacement of the particle in vertical direction? It should be mentioned as the height. So this is the maximum height attained by the particle. So s can be replaced by h max, that is maximum height. So you just substitute all the values. What is the value of Vy? So 0 equal to uy u square sin square theta plus of 2 into, what is the ay value? Minus of g into h max. Am I right? By simplifying this equation, 0 equal to u square sin square theta minus of 2g h max. Now I am going to find the value of maximum height. So it is presented in this side. So I am going to shift this side into the LHS. So u square sin square theta is equal to 2g h max. That is a maximum height. You knew the expression of maximum height expression. So h max is equal to u square sin square theta divided by 2g. Very important relation. In a cricket stadium, the particle or the ball, how much of height is reached? That should be calculated by using this formula alone. So the maximum height by the projectile can be calculated u square sin square theta divided by 2g. And then next I am going to find time of flight. What is time of flight? In a horizontal projection, we already told you the time taken by the projectile to hit the ground. Am I right? Here, the time taken by the projectile from the starting point, that is foot of the tower, to again which point is going to hit the ground. So this much of time is traveling. Am I right, student? So the distance is traveling like in the x direction. So I am going to take it as a second equation of kinematics. What is the second equation of kinematics? Time of flight. Time of flight. It is represented by TF. Very important formula, students. TF. So time of flight. I am going to take the second equation. Sy is equal to uy of t plus of 1 by 2 a t square. What is the displacement value in vertical component? Sir, there is no displacement in vertical component, sir, because we are going to find the time of flight. So Sy, I am going to take it as a displacement. Sy can be 0. There is no displacement. There is no height. And what is the value of uy? Initial velocity can be written as u sin theta. And then what is the value of a? Acceleration of y component is ay is equal to minus of g, and then t can be replaced by tf, t suffix x. So t suffix x represents time of flight. So now I am going to substitute the values. The sy value becomes 0. So 0 is equal to u sin theta into tf, that is the value of t, plus of 1 by 2 minus of g t square f. I need the value of time of flight tf. So minus into plus minus. So 1 by 2 g t square f. I am going to shift this side. So 1 by 2 g t square f is equal to u sin theta into tf. So t square f is equal to u sin theta into tf divided by g into 2. Am I right? So I am going to simplifying. TF will be cancelled. So the final result of time of flight is TF is equal to 2u sin theta divided by g. Very important equation, very important formula. So the time of flight is mainly depends upon the initial velocity. Okay? And then next, now I am going to find out the horizontal range. How much of distance the projectile will cover if you suppose to apply the constant velocity. So very easily we can find the horizontal range. Horizontal range. Horizontal range. What is the range formula in before class? So range can be found by horizontal velocity into time of flight. Horizontal velocity into time of flight. You know very well the horizontal velocity expression. So the range equal to horizontal velocity u cos theta into, what is the expression of time of flight? 2 times of u sin theta divided by g. Am I right? So here by simplifying this equation, u and then u, so 2u square sin theta into cos theta divided by g. Do you know one thing? The sin 2 theta formula can be written as 2 sin theta cos theta. So here 2 sin theta cos theta can be replaced by using the sin 2 theta. So the range equal to, horizontal range equal to u square sin 2 theta divided by g. Very important expression, students. The horizontal range R is equal to U square sine 2 theta divided by G. Students, listen here. If you want to suppose to reach the projectile at a maximum distance, at what angle you should be project? By using this equation, you can easily find out. Sir, shall we take it as the theta becomes 0 degree? What will happen? Sine 0 equal to 0. 0 into anything? 0. Because there is no projection. There is no range of projection. Okay, sir. I am going to fix the value of theta equal to 30 degree. What will happen? Sine of 30, that is 2 times of 30. Sine of 60 is root 3 by 2. So it will become the smallest range. Okay. Suppose now I am going to fix the value of theta equal to 45. Students, listen here. Theta becomes 45. I am going to project the particle at the angle of 45 degree. So if you are supposed to project the angle of 45 degree, so sine of 2 times of 45 becomes 90 degree. Am I right? So U square sine of 90 divided by G. So sine 90 becomes 1. So this much of angle provides a maximum range of particle. So if you are supposed to throw the object at the angle of 45 degree, it will be covered the maximum distance. So the effective projectile range is at the angle of 45 degree alone. Okay, students, very important 5-mark question. Go through well and all the best.